In this video, we're going to talk about coterminal angles. So before you attempt this lesson, just make sure you're comfortable with looking at angles in standard position and identifying their quadrants. So one of the benefits of forcing angles to be in standard position, where we have one side always being the positive x-axis, is we can talk about bigger angles. So if we're just talking about a triangle or any type of polygon, we can never talk about a 370-degree angle. It really wouldn't make sense. But in standard position, we can actually make sense of this. What should a 370-degree angle look like? If we're in standard position, we have our one side on the positive x-axis, and we know the quadrants have these points that break up. But 370 is bigger than 360. It's not between any of these numbers. But if we think about the fact that we're just kind of rotating clockwise, we rotated all the way around to 360, and that's not enough to talk about the angle that I want to talk about. But if I think about that, it just means there's a 10 degrees left. So I just go another little 10 degrees and I get that. So this angle I've rotated around all the way past 360 and then a little bit extra. This is my 370-degree angle. All right, so we can talk about these bigger angles, and this makes sense because you're talking about like something spinning. It can spin around a lot. It can create these bigger angles. All right, so now we can talk about angles that are bigger than 360, just knowing they kind of rotate around your axis more than once. All right, so once you have an angle that's bigger than 360, it's just going to look like any other angle that is between 0 and 360. So if we think about that last example, this angle here, which went all the way around in there, that's 370. That looks the exact same as if I had just done this, just a small rotation, and done 10 degrees. So when I draw these angles, they look the same, and that means they're called coterminal angles. So our definition down here, coterminal angles are just two angles that share the same terminal side. That's kind of the fancy term for this line here. But basically it just means they look the same when I draw them. So if I draw the 370-degree angle, if I don't put those little rotation marks, this is 370, and this is 10. They look the exact same. All right, so that's what coterminal angles mean. It just means they look the exact same when you draw them. All right, so we want to find the smallest positive coterminal angle to an angle. So if we have these really big angles, we want to know what would it look like if I was just between 0 and 360, because that's easier to work with. All right, but 475, definitely bigger than 360. So what we've done is we've taken 360, and we've rotated a bit more to some point. That might not be exactly what the angle looks like, but that's the idea. So what I could do is just kind of just get rid of one of the rotations of 360 and look at a smaller angle. So what that means is I'm just going to take 475, I'm going to subtract 360 degrees from it, because that's a full circle, and it's just going to get me back to kind of a starting point where I'm just worried about the smaller angle. So I just do 475 minus 360, and I get 115 degrees. All right, so 475 and 115 look the exact same. 115 is easier to work with because now I can identify the quadrant that's in quadrant 2. I know it's in quadrant 2 because it's between 90 and 180. What about a negative angle? Well, a negative angle, we know we just rotate in the the clockwise direction. But what I can do, similar, instead of subtracting off 360, I can add on a revolution, and it's going to cancel out these ones and just give me this angle, this nice positive angle that I want. So I can just add on 360 to a negative angle, and that's going to give me negative 125 plus 360 is 235. All right, so that's getting the angle 235 degrees. So negative 125 and positive 235 look the same. It's a little bit easier to work with positive angles than negative angles, and this is in quadrant 3. It's in quadrant 3 because it's between 180 and 270. So it's a lot easier to work with these simpler angles and just adding or subtracting 360 to get smaller or positive angles. All right, so the general strategy is if the angle is positive, subtract 360 until you get an angle smaller than 360, and that'll be the simplest angle. If it's negative, you just add 360 until you get a positive angle. And 360 is a full circle, so every single time you add or subtract 360, you're not going to change what angle you're talking about. So 360 is the special important number. All right, so here's some ones for you to try on your own. I found the smallest positive angle coterminal to these, and just one hint that I haven't done in the other examples, you might need to do the 360 part more than once. All right, so go ahead and try those, and I'll show you the answers in 3, 2, 1. And here's the 2 answers that you get. And you just keep doing this process until you get an angle that's the right size. So for 895, if I subtract 360 once, I get 535. That's still bigger than 360. So I do it again, and I get 175. So that's my nice angle that's smaller than 360, and I know that's in quadrant 2 because it's between 90 and 180. The negative one, for negative ones, you just add 360 until you get a positive. So I add 360 once, I still have a negative angle. Do it again, still have a negative angle. Do it again, finally get a positive angle. That's the one that's going to be smaller than 360, and 310 between 270 and 360. So it's in quadrant 4. All right, so go ahead and practice working with coterminal angles. I add and subtract 360 depending on if you have a positive or negative angle. And at the end, just determine your quadrant based on where your angle lies.